I seem not to be able to hear anybody. Is anybody talking?
Sorry, we were muted. Okay. We're recording, so this is a public and recorded meeting. So welcome to another TST meeting for ONOS. Today we thought we would give a progress update on the micro ONOS effort, specifically in the ONOS config subsystem. And we have a couple of people that are going to be doing just various, not ad hoc, but rather informal presentations. We don't have to necessarily do them in this order, but we have a couple of things to show you. There are some Atomics, gRPC, and Go client libraries that Jordan's going to show us. We have various configuration enhancements for be able to use how to use GNMI extensions on a northbound to be able to target configurations for specific devices. There is also a device simulator GNMI enhancements that allow us to test error returns, subscription streams, and things of the sort. Ray, you should be able to provide a test of a simple end-to-end test script and things of that sort. Do we want to go in this order? Jordan, are you ready, or should we should we do it in different order?
Whatever you think makes sense. I'm fine to go.
If you're ready, then why don't you get going? Why don't you start, because I think yours is probably the heftiest, I would assume. So I'm going to make you a presenter.
Okay. Yeah. So I'm not going to get too real in depth with this because I'm pretty sure that at a later date I will go a lot more in depth to the things that I did. But just a couple slides here. So I mean, basically, what I was doing, what I've done over the last several weeks is started work on basically updating the Atomics API to work with different languages and work with our new microservices and things like that. And so some of the principles of this effort that I outlined late last night were, yeah, so I mean, the goal is to create a well-defined backwards compatible polyglot API that's suitable for ISSU and things like that. All the way down to the stores. Try to make the replication protocols, Raft and primary backup and things like that a lot more lightweight. Reuse code, obviously, which is always important. But one of the important tenets with, I think, several components of the system that I've seen is to try to rely on other systems to do more, especially in this case, Kubernetes. So I'm trying to offload a lot of the work that was previously done by Atomics itself to Kubernetes, since we're deploying in Kubernetes. I'll show you how what I mean by that. And then one of the other important tenets is in this refactoring effort, what I've tried to do is push more information down to clients, which means down through gRPC to clients written in different languages. And what this allows is for client libraries to be much more rich and for them to have a lot more features and for them to implement the types of strong consistency features that previously the Java client used to implement. And I'll show you the APIs and how they do that. So the way that the way that I sort of restructured, I mean, most of this effort was just restructuring code and adding APIs that makes sense. So the structure of the code that I came up with, this is sort of like from a high level down to a low level, and I'll show the actual code in a minute. So at a high level, there's a management API. So this is these are protobuf services basically for managing partitions. And the component that implements this API is called the controller. So a controller is basically a component that, this is the component that offloads work to Kubernetes. So instead of Atomics setting up partitions and managing cluster membership and stuff, the controller just exposes an API and then tells Kubernetes that it needs to deploy some partitions. And I'll show a drawing of this also. And then at a lower level for the actual primitives themselves, there's another set of protobuf services which expose methods for operating on maps, sets, and locks. And these look a lot like the Java primitives did previously, but they're protobuf services. And then these primitive APIs also provide session management information that's pushed down to clients for strong consistency and things like that. And then what an actual node is in this case in Atomics is much more lightweight than before. A node basically is just a container that runs basically a single protocol. So rather than a node running many partitions, basically, I mean, previously Atomics ran basically many RAF servers, many of different kinds of protocols all on the same JVM. And this has sort of been refactored to where a node is just a single instance of a protocol. So a node now looks something like what a normal etcd node or something like that looks like. And then of course there's still an abstraction for different protocols inside of the node, or the server can run various different protocols like RAF, primary backup, etc. And then so that's like those are like the sort of components that are deployed. And then inside of the actual Java API, there's, of course, a state machine API, which is what provides the primitives. The kind of cool thing that I'll show you is the state machines, in addition to exposing primitives via protobuf services externally, the internal state machines are also specified by protobuf, and code generation is used to generate abstract state machines that are then implemented in Java code, and I'll show you some examples of them. And then I'll show you some examples of client libraries that actually use these interfaces. So yeah, I know this probably sounds kind of confusing, but let me show you sort of what some examples of the code look like. So this is currently being done in a branch in the Atomics repository. I'll probably end up, once this gets cleaned up a little bit, splitting up some more of the code into different repositories. But yeah, currently this is like in a single server branch. There's, in the Atomics repository, there's this API module. So the API module is what defines the protobuf services for basically for managing partitions and for operating on primitives. So an example of what a primitive looks like is, for example, map is the most, like probably the most common primitive that we used previously. So the map, yeah, so the map service looks something like this. And so this looks a lot like what sort of the Java primitive API looked like before, right? There's a, can you guys see that, by the way?
Yeah, we can see it fine.
Okay. Yeah, so I mean, yeah, so there's this, I mean, yeah, it looks pretty close to what the Java API looked like previously. One of the cool things that I managed to implement is, for example, you see, I mean, previously in the Java API, we always had event-based notifications, and that carries over into gRPC. And I managed to figure out how to adapt gRPC streams. So in this case, for maps, you call this events RPC and get back a stream of event responses. And I managed to figure out how to, I mean, there are a lot of very complicated details about producing events from Raft to a client in a consistent manner where events occur I mean, there's a lot of like details about ordering events with writes and reads. And I managed to integrate streams into the replicated state machines on the back end so that that sort of consistency could be maintained in the same way it appeared to be maintained with events through the Java API.
Great.
Yeah, and so, I mean, each request basically, the actual messages, they have something that's a primitive API, so, I mean, a primitive ID. So the primitive ID is a name and a namespace. And then you'll often see headers. So these headers carry the information about how the client wants the request to be ordered with other requests, and it sends back information that's needed for the client to maintain consistency, like indexes inside the replicated state machine, session information, things like that. So that's like an example of what a primitive service looks like. And then for actually managing partitions, what clients do is they use there's like a partition service. So this is the service that's exposed by the controller. And this just, the primary function really is this, which is for a client to be able to, in Kubernetes land, request from the controller, which will request from the Kubernetes API, a list of the partitions and their services so that the client can connect to them. Yeah, so that's the public API. So internally, yeah, so that's implemented by the server, but additionally, internally, all the protocols, like for example, Raft, basically all these modules are now using protobuf. So all of these, like internally in Raft, this is a specification of the Raft consensus algorithm, basically a protocol for Raft. So joining cluster, leaving cluster, reconfiguring, pulling the coding algorithm, replication, snapshot management, things like that. And so this is all now specified in protobuf and implemented in using gRPC. Let's see what else. Yeah, and then the other thing is that also the configuration is specified in protobuf messages. So these actually, there's a mapper. So there's a component that maps YAML configurations to protobuf messages. So when the nodes are actually configured, the YAML is parsed and it's converted into, like in Java, there will be a Raft protocol config message, which is given to the protocol to configure, for example, the storage directory, the Raft log information, things like that. So there's a very heavy reliance on protobuf. So that's the, yes.
I was gonna say, this is great. This is awesome.
Yeah. Yeah, one more thing. And then, as I was saying, yeah, so that was the, that's not what I want. Yeah, so I showed you basically the external API which clients connect to, and then an internal example of what a protocol uses. So in addition to that, as I was saying, the actual replicated state machines themselves are specified as protobuf services as well. So a replicated state machine looks something like this. So this is what the locks replicated state machine. This is basically specifying the interface that the lock replicated state machine exposes. And so the important component of this is the lock. The lock state machine basically says, provides a lot of additional information about this stuff. So this is a write. So writes and reads have to be treated differently in replication algorithms. So this is, yeah, there's like, for the lock service, there's a lock, unlock, and is locked RPC, and this looks pretty similar to what the public API is, but this contains information that's used internally to actually create the replicated state machines and understand how gRPC requests can be serialized to things like the RAF log and replicated and things like that. And so the product of that is, let's see if I can find the lock state machine here. Yeah, so this is what the actual lock state machine itself looks like, and it basically implements something that looks like that protobuf service that I just showed you, which the protobuf service had a lock RPC. This is the protobuf message, lock request, and lock response. And so these messages, in the case of the state machine, are messages that have been received by some protocol, wrapped or something, and replicated, and then given to the state machine. Yeah, I think that's most of the protobuf stuff from the perspective of the server. So real quick, I'm going to show you an example of how this is actually used in a client library. So I haven't been updating this. I think it needs to be updated a little bit since I've been making changes lately, but I started working on a Go client just as, since we're initially using Go, and just to make sure that everything's working well. So this Go client library, so it's called Atomics Go, you can go check it out. Basically all it's doing is pulling that API module from the Atomics repository and building the protobuf files, building Go code from the protobuf files. And then the actual client's API, so inside the package/client folder, there's the client API, and it looks, it looks pretty much like you'd expect. So you create a new client, which is just connecting to a gRPC service. And then you can create instances of different primitives, right? So there's a map primitive, and this is pretty similar to what the Java API used to look like. Right, a map primitive, a lock primitive, election primitive. These are the primitives that I implemented just for testing purposes. And so yeah, you can get an instance of a new map, and then what those actual APIs look like, you can actually look at the tests. So I wrote pretty decent tests to test this out. And this is like an example of the lock primitive test. This is creating a couple locks that are going to fight with each other. And yeah, so this is like locking the lock, checking the lock, attempting to lock another lock concurrently, allowing the other lock to acquire its lock, etc. And this is done in the way that these tests are set up. I sort of like, so basically it's creating like a local, it's creating a local gRPC server, registering a lock service, and then I essentially implemented the state machine logic for something like the distributed lock in Go. So this is sort of like a duplicate of the actual logic that's used in the Java version of Atomics, but this is used for testing. And so the kind of cool thing is that we can potentially reuse these service implementations in tests in other areas of the code that are using primitives in other Go code. That is, we can reuse these test state machines for testing other code that relies on the primitives. So that's pretty much all I have. Yeah, I think down the road I'll have a lot more detailed talk with lots of pictures as I want to do. So.
This is great. This is great. When do you think it will be ready? Or I should rephrase the question. When do you think it will be ready to start working on the config store stuff?
Yeah, so I'm planning. So I think I think I'm going to be able to start on that in probably 2 weeks. So,
wow. Excellent.
yeah, I mean, it's working. I've been testing it along the way. The only thing that's left really is to essentially get it deployed inside Kubernetes so that we can actually connect to it from, and then clean up the client library, which that stuff will probably take me next week. And then we can start at least playing with it in the ONOS config.
That's awesome. Thanks, Jordan. Excellent. Alrighty. So let's bring up what's next. Sean, do you want to go next on GNMI?
Yeah, Tom, if I can.
Yep.
So maybe if you, or well, I can share my screen here. I have, or there were those slides actually. Do you have the slide back? Or maybe I can just get it here.
Let me share the. Let me make you a presenter.
Yeah. Okay, so let me just get the slides here. Can you see this? Can you see the slides I'm presenting?
Yep.
Yes.
You can.
Yes.
Let me just present here. So really, this was about extending the GNMI interface, right? So basically, northbound out of ONOS config, we are presenting a GNMI interface to whatever orchestration system or whatever sits above us. And what we're trying to do is, like, GNMI was meant for individual devices, and what we're trying to do is give it a purpose that can, allow us to access a system that's now managing several devices. And what we want to do is be able to make a change to several devices at once in one GNMI set command. But also we want to, maintain lots of other functionality like rollback or, tracking of changes and, various different things that the ONOS config is going to support. So to support those extra use cases, we added an admin interface. So admin now is a protobuf definition that has rollback in it, right? There's no equivalent of that in GNMI. But for dealing with things like having different versions of a config for a device, or dealing with, managing configurations that deal with different software versions of a device, I might want to do it through GNMI. And so GNMI has an extension mechanism. Now, what we didn't want to do is make it too complicated. So basically, if you didn't want to use extensions at all, then you can use the thing and you wouldn't see any difference. You can use single device versions and it won't make any difference to you. And the idea here is that, if somebody comes along with an orchestrator that sits above us that talks GNMI, can handle models and handle sets and gets and all of this kind of stuff, we don't want to break their interface. So that was one requirement for this, is that this thing should work without using extensions. So they're there as a convenience for being able to do lots of things through the GNMI interface. So just to give an idea, what are they? They're a set of numeric identifiers with a string value that you can add onto a GNMI call, like, say, for instance, set. Okay, so I randomly picked 100 as a starting point for the name of a network configuration change. Okay, so the numbers can be 0 to 999, right? So I didn't want to risk, running over anybody else's set of numbers, so I started at 100. And so when you do a set request, you're doing it against ONOS config, and you might be changing several devices at a time. And I wanted to give a name to that change, right? And because I want to be able to refer to that name in future to do things like rollback. There is a default here that if you don't give a name to this set request, it will generate one for you, and it actually generates one now in the Docker style format of, you know, what is this, happy, you know, happy Einstein or something like this, you know. But if you wanted to give it a specific name, you can do that with this extension number, okay? And I'll get into, you know, some of the other things I have. Basically, I'm proposing that we use 101 as a device version. So say, for instance, we have a configuration in our store, and it's for device number 1. But say we have a second configuration for device number 1 in there as version 2.0, then this 101 allows me to discriminate which of those configurations I'm doing the set to, okay? Similarly, you know, I might want to do a get, and, you know, I want to get maybe all devices of a certain version or something like this, so I can use this extension 101 as a discriminator in a wildcarded get request. So these are the kind of things I'm, you know, talking about. Device type is a kind of a label that a device can have inside our system, and this allows us to, you know, if we're creating a new version, to set a device type, and also to, the other thing is, you know, to specify a model data set on a new configuration. And I will give examples in this in a minute to illustrate it with more detail. So there's a number of use cases that it's supporting, right? So say, for instance, if we want to do a set, and I'll give an example of this on the real system. You know, if I give no extension, if I don't give number 100, then basically it goes off and it, you know, finds configurations for this target that I've set, you know, device 1. If there's only one configuration, it says it must be this one, and it makes the update and it returns, and it generates the set response as extension 100. Actually, let me just show an example of that. So I have my system here, and I'm going to start ONOS config, and it connects to my 3 devices. I've got device simulators running, and what I have is I'm just going to go to my notes here, and I'm just going to copy some commands from it. So the first thing I'm going to do is I'm just going to do a get. Sorry, just to give the lay of the land here first. What I wanted to do first is to show you what I have configured on the system, right? So this is my config store. Okay, so basically I have 6 devices or 6 entries in my configuration store. Okay, so I have device 1 with version 1, I have device 2, and it has 2 different versions. And then I have these 3 devices which are of type device simulator. Okay, and device simulator, you know, its name is localhost, its version is 1, it's a device simulator, and it's supporting these 4 models. Okay, and that's how I'm representing the device inside my ONOS config. And I have I have 3 of those types of devices. Okay, so there's 162 and 163. So let me just go back to here, and I was going to do the get on localhost 10161. And copy it. Okay, so this is going to do true ONOS config, right, which is 5150. I'm going to get the configuration of 161. Okay, so it's going to read the time zone from it, So it's going to read the time zone, and off I go. So it reads the value. It's Europe Dublin. Okay, so no problems there. I did a simple set, and there's nothing to worry about, right? So I'm doing a simple set here, and what I'm doing is 161 again, right? And I'm going to change the time zone value to Paris this time, right? And so what I'm doing here is I've made a set, and now you can see in the extension I get registered value 100, and it's created this set. It's given it a name using Lalande, okay? So I could go into the net changes administrative utility, and I can see the history of configurations that I've made, network changes as we call them, okay? So basically it's telling me that musing Lalande was in there. It's basically changed localhost 161, okay, version 1.0. And it's given this change to it, and I can look into what these changes are. But like at the end of the day, if I do a get on it, it's showing me that the value of time zone is now Europe Paris. So what I was going to do is I was just going to do a set this time, and I pasted it very quick. But basically what I did is I set an extension. So I set extension 100 in it, and I made the name of this change being Sean's change, okay? And so you can see the value is replied here, Sean's change. And if I do the, and I changed the time zone to Helsinki. So if I do the get, I get Helsinki. And if I do the net changes, I can see now that musing Lalande is still there. Sean's change was layered on top of it, okay? And so what I was going to do is show how I do a rollback, okay? So I'm going to copy this command like this, and so now I'm going to roll back the Sean's change, and this should give me success. And that's the reason I would like to give the thing the name, is because I need to use the name when I'm rolling back. You can actually do rollback anonymously as well. It'll roll back the last change, but this one rolled back Sean's change. So if I look now at net changes, Sean's change is gone. If I look at the configuration, it's back to Paris being the time zone, and I'm just gonna roll back a further one. And so what this does is, because I haven't given it a name, it's going to roll back the last change, which will be musing Lalande. And if I do net changes, basically I can see that it has no network changes remaining now at this stage. And if I do a get, it's back to Europe Dublin. So basically, that's kind of what I'm saying is, the power of the extension is it allows us to still use the GNMI interface and take advantages of internal constructs in our ONOS config.
So this reminded me a little bit of like git commits and the ability to check out a given commit. I'm assuming you can jump to essentially any level of the commit tree you want. Not just one at a time. I can go back 2 or 3.
So at the moment, what we're planning is you would have to do them individually. You would have to go back step by step.
Okay, so you can always only roll back the last one right now.
Yes, and yes, that's it. The trouble with going back several steps is, somebody, say for instance, I had a change that affected device 1 and device 2, and then went on and made further changes to, we'll say, device 2. Now I can't just go back to device 1 without rolling back the other change I made to device 2.
Yeah, I agree. It does get complicated. All right, cool. Thank you.
So we're going to keep it simple for the moment. Okay, so one other thing I wanted to show was just the concept of versions. And you saw earlier when I showed the configuration, I had 2 versions of device 2, and I didn't copy that. So what I'm going to do now is I was going to try and make a change to device 2, and so this change, my target is device 2, and it gets rejected, saying that 2 configurations were found for device 2, right? Version 1 and version 2, and what it's asking me to do is please specify a version in extension 101. Okay, and so now I can go and do that. So this command basically has extension 101 in it, and I'm saying actually I want to make the change to version 2, and so now it goes off and it makes the change to version 2. So really what I wanted to show here is that these extensions allow us keep the structures of GNMI without having to to revert to doing strange things and dealing with internal mechanisms through the admin interface. So really that was all I had. I think I had covered most of what's in the slide. One, I don't have all of these things fully implemented yet, but like one of the things I wanted to do is, if you were to do a new device configuration, you would be able to give a version, that should say 102, a device type and model data, so that you would be able to do the whole lot through GNMI. You'd be able to give the change, give the version, give the device type, and give the model data, and now you would effectively be able to create a complete configuration instance like this with all the required parts such as version type and models, all in one go through GNMI just by extending it with these extensions. Okay, that was it, Tom, from me.
That's great, Sean. Thanks. What do we have next? So, what do we have on the agenda? Do you want to do the device simulator?
Yeah, sure.
Adi is gonna go over some of the changes that were done to the device simulator.
Can you see my screen?
Yes.
All right, great. So, as you know, we moved the code from the GNXI toolset to our repository. So I implemented subscribe once and pull so far. We had a problem. Originally, I was thinking to move just the GNMI target, which is a wrapper on top of a server. But the problem is that we still need to move the original server as well for the subscribe. So let me give you an example why it doesn't work if we just override the function in the GNMI target. The reason is that when we call a set function, in the wrapper, the original set function will be called from the original server. It means that the config store will be updated in the original server, not in the GNMI target. So if we use subscribe, so subscribe gets the old value. So what I did, I defined the data structure in GNMI target, initialize it when I create the new server. I moved the code from the original code, the server, and added a function getConfig to retrieve the new value and new config store from the original server in the GNMI target when I call set function. By doing that, so the data structure will be up to date all the time. So, and to show you how it works, here, let me move this. A target is running here. So I have a target running in the left side, and this is an script which has the command line for the subscribe once. So when I run subscribe once, so it retrieves the value here, for example, the time zone. So I have a set I want to change the time zone. I change it to something else. If I run subscribe once again, so it changed. It changed to Spain. So, and for subscribe poll, if I run subscribe poll, it keeps polling every 5 seconds and prints the value on the screen. So if I change set to another, for example, to Italy, let me change it. If I call set again, so the value will be updated. So we have subscribe pool, subscribe once. So, but again, so I moved the code, the original code, the server code. So I try to avoid that. So just change the wrapper, but the problem is that we need the configure store.
Right. I just didn't want to do that for just the air alone. Remember what you and I talked?
Yeah.
So back. We were discussing this.
Yeah.
I just didn't want to make the whole move of the whole code base just to return one error value. But for something like this, where we actually are embellishing further and deeper,
yeah,
it makes perfect sense.
So this is one thing. And
so do you have subscribe once and subscribe poll? So you're working on a subscribe
stream. The stream needs more work because I need to implement a listener. So at least to stream the events whenever there is a change. So as you know, in the GNMI specification, there are lots of details for the stream. So some of them are optional. For now, what we have in the code is just whenever there is a change, so we stream the events to the client. So I would like to have that one at least in the device simulator as well, that we can test the functionality that we have in it. And I think now we can test the Southbound interface. So if I find time after doing all of this stuff, because I just moved the code, so I need to update the Docker file, make sure that it builds, and then I submit a pull request to merge these changes, and then we can test the Southbound interface.
Yeah, Adib, to test the Southbound interface, I'm working on a patch that changes a few things to enable operational state, and in the meantime, I found some things that I didn't particularly like about the subscribe implementation in the Southbound. So I'd probably ask you to hold on until I push that patch.
Sure, that's fine. Because I'm still working on the device simulator. So my plan is to finish this stuff this week. So when you are done, let me know. I will test it. If you want to test it yourself, that's fine as well. So I have that to do.
Thanks.
Yeah, Adib, yeah, good work. I think it's probably in stream mode that we will connect through the Southbound interface. Am I right there, Andrea?
Yeah, precisely. I will do two things. One is initially a GET request to populate my operational state cache. And the second one would be subscribe requests for every path. And then we would also probably issue a subscribe on a specific set of paths.
Yeah, on the operational state paths. But that would be a stream call rather than a poll or a once, I think.
Yeah, it would be a stream.
Yeah. So that's an important one to implement as well, Adib.
Yeah, that's my plan to do that. So I wanted to make sure that we can have just basic functionality of subscribe. So because subscribe once is easy, poll is also easy. But for a stream, we need to keep track of the changes.
Yeah, very good.
Okay.
Great. Thank you, Adib. Okay, and I think next we have Ray. Can you give a demo of the?
No, I can't give a demo, but I can show the script.
Okay.
Actually,
I'm sorry, Ray. Was that my change?
I had no idea I was going to demo this today, so
No.
I would have checked it.
No. It doesn't matter. We can just at least go over some of the stuff.
So the background is
guys,
that.
Are you
guys,
joined?
if you don't mind, I'll actually go next because what I'm going to show is fairly similar to what Adib showed, but to the subsystem we have.
Sounds good. I'll make you a presenter, Andrea. Sorry.
Okay. Can you guys see my screen?
Yes.
Mm-hmm.
Yeah, so I'll keep it short and sweet. The idea is that there is, I want to show the capability of doing subscribe from the northbound of ONOS config with any of the poll, once, and the stream capabilities. The idea is that I'm going to follow the documentation, so whatever I do, you can do it too on your computer, wherever you deploy it. I'm just going to run the server locally and then do a set of things, meaning first one, I'm going to do a subscribe request for notifications, then a subscribe once to just show the value, and then a poll request. And I'm going to show these things with a set. So here is a little bit maybe too small. So here I'm just running the service, the GNMI, the ONOS config manager. That is the entry point for the whole ONOS config workflow. And then here I have a subscription with mode 2, which is the poll. And when I start that, it immediately retrieves me one value, and it starts polling every 5 seconds because that's what I specify in my request, both in the sample interval here and also in the polling interval here. So that's every 5 seconds it does a poll and it returns the request. Here I have a subscribe mode 1, which is just to give me a subscribe once the value that I'm asking for. In this case, it's time zone name, and it's just gonna return me Europe Dublin. But then what I wanted to show, and I'm gonna copy paste this because it's simple for me. I'm gonna show you that I'm gonna subscribe to 2 things. One is a subscription with the wrong path. I would encourage you to take a look at the fact that I'm subscribing here to just name and not time zone name as it is here. So with this error, I will basically leverage this error to showcase the filtering that we do. So here I'm subscribing to the wrong one. And in this one, I'm actually using the right time zone name. So I'm actually subscribing to the right event. And as you see, there is nothing here because nothing is changed. But whenever I do a set, which is this one here, I'm actually changing the time zone name to Europe Paris from Europe Dublin. You kind of get the gist that we use this as an example. I make that change. Oh, sorry. Not in the right direction. I make the change, and you're going to see that the polling one will, in 5 seconds, turn to Europe Paris. The one with the right path got an event. This is the subscription event that gets bubbled up. The one with the wrong path has subscribed for a wrong path. So it's not a wrong path, it's subscribed for a different path. So having nothing updated on that path, it didn't get a notification. That is done through connecting it to the store, so it does not actually go through the device. And this is a deliberate choice because we're using ONOS config as the unique source of truth to the configuration of the device. Meaning that as soon as something changes in ONOS config, we can actually expose it on the northbound without having to go on the device itself. We're going to use the same streaming service that you see here on the northbound of ONOS config to upstream operational state changes from the device, and that's what I've been discussing a little bit before. Basically using an operational cache that keeps track of changes. It populates it with an initial get. After the population of the initial get, it subscribes to all of the paths that are operational state. And as soon as the device changes something, it pushes it up on the same channel that I use to receive notification in the subscribe northbound. And then the subscribe northbound would receive notifications of things changing in operational state in the device. It's kind of what I have. All the commands I ran are in the run.md file. The thing I want to put your attention on is the mode. That 2 is the poll, 1 is the subscribe once, and 0 is the subscribe stream notification. We will have to probably extend this to show some of the extensions that Sean did for some of the configuration if needed. That's about it for myself.
Thanks, Andrea. This is great. So Ray, you can show us the coverage stuff, right? At least the work in progress things. Is that right?
Yeah, I can show you the unit test. The coverage stuff doesn't work at all either. I'm not having a good day. Sorry.
No worries.
I don't want to do that. Share. Let's see this one. Yep. Okay. Gotcha. So those of you who have not been working on this project will note that in what Andrea talked about and what Sean talked about, you see these obnoxious command lines with this GNMI tool, which has a very verbose command line. And so I decided that I wanted to have something kind of self-contained that I could just do a basic test. I was playing around with the GNMI client. I wanted to make sure that I didn't break the northbound connection all the way to the southbound. So at the same time, Jordan will tell you, I botched the creation of the Minikube local Mac Kubernetes instance multiple times. And so I decided, hey, I might as well script that too. So it's not very exciting to look at shell scripts. I was hoping to show it, but some changes in the northbound API made it not work this morning. So bear with me here. So this first script here essentially takes what Jordan had written up in the deployment document. It creates a Minikube instance, which is sort of a self-contained local Kubernetes that will run under VirtualBox. So I bring that up, and then this stuff is not all that exciting, but it uses Helm to install first the device simulator, so I get a southbound, and then it brings up the ONOS config, which is the northbound, and then it runs this changes thing, which just makes sure that, hey, I can get all the way through. So this is takes a fairly long time. It takes about 15 minutes. I'm not sure what Kubernetes is doing, but there's a lot of queuing and downloading and various other things. I'm sure I can optimize it. The idea behind these two steps is in the current ONOS, we have something called STC, which stands for, what is it, Scenario Test Coordinator? Scenario Test Coordinator, which is basically a way of doing reproducible integration tests. I really want to have that for this product as well. So this was kind of a poor man's attempt at doing that locally. The next script, this one looks a lot like what you've been seeing Sean and Andrea do. It's using the GNMI CLI command. Now what this is doing is this is basically making a GNMI request to the northbound of the ONOS config. And then it's testing that what it's getting back is what it expects. It's doing a very simple right now set of operations. The first one is query that the device is really there. Then it tries to do a set of an innocuous thing, which in this case is the time zone. Tries to do that again, which is an error, and it checks that the error is actually there. And then it is going to do a get to make sure that the change actually went through. So anyway, this script is not very exciting. The idea is if we can roll this into something like an STC scenario, then we can do automated testing end-to-end, which we currently can't do with unit tests. And at least in the existing ONOS, we found this to be really useful for finding kind of DOA type situations where changes were made that people didn't understand sort of how the north and the south work together. So that's kind of the goal here, is to be able to encapsulate this into something that's deployable on like Amazon. Yep. Once we do that, then we can run it as part of CI. And that's the real goal. This is just play stuff to make sure that it actually, that I can get the basic stuff working, but the real goal is to get it as part of CI.
Sounds great. Thanks, Ray. So we'll hold another TST meeting 2 weeks from now, unless there is some other item on the agenda or some other topic on the agenda, we will probably continue to cover the progress being done on µONOS architecture, because it's moving forward rapidly. And again, I would like to use this opportunity to invite people to clone the repo, join the meetings. We also have stand-ups in the morning. They're on the ONOS calendar. So don't hesitate, just because there's a group of us plowing forward, please don't hesitate and join the effort. Help is always welcome. Thanks, everybody.
Let me take the time to ask if there are any questions from anybody.
We don't have time, unfortunately.
Yeah, unfortunately, we have to end because there's another meeting starting right now. So
okay, sorry about that.
Okay, no problem.
Take care. Bye-bye.
Thank you. Bye.
Bye-bye.